Hello everyone, myself Govindaraman, currently pursuing my computer science and engineering degree in Sri Venkateshwara College of Engineering with AI as my specialization. So the subject is microcontrollers and embedded system. In this video or the presentation, we'll be studying about microprocessors and microcontrollers used in computing world and its specifications and applications. So, as we know, microcontrollers and microprocessors are the backbone of modern computing industry or the technological industry. In this presentation, we will be exploring its types, specifications, applications, and differences of microprocessors and microcontrollers. Let us see the contents part. So in this presentation, we'll be studying about what is microprocessor and its types, applications and specifications of microprocessors, and what is microcontroller and its types, applications and specifications of microcontrollers, and the differences between microprocessors and microcontrollers, and last, we'll be studying about the conclusion. Moving on. What is microprocessor? Microprocessor is basically a CPU which is built on a single integrated circuit, that is IC. So it is basically made up of millions of semiconductor transistors, diodes and resistors, and it is responsible for any arithmetical and logical operations. So below you can see a block diagram of microprocessor which consists of ALU, control unit and resistor array, where the ALU performs arithmetical and logical unit, where the control unit controls the instructions and flow of data within the computer. Types of microprocessor. It is classified into three types based on application, which is general purpose microprocessor and special purpose microprocessor. Based on architecture, it is classified into four types: RISC architecture, CISC architecture, VLIW architecture, and superscalar architecture. Based on bus data size, it is classified into five types, which is 4-bit microprocessor, 8-bit microprocessor, 16-bit, 32-bit, and 64-bit microprocessors. CISC. CISC is an acronym of a complex instruction set computer. The microprocessor is designed to execute complex instruction, which minimizes the number of total instructions per program. So you can see some examples which are Intel 386 and 486, Pentium, etc. RISC, reduced instruction set computer. This type of microprocessor is based on architecture designed to execute simple instruction. The instructions are simplified to reduce execution time. Here are some examples: AMD K6 and K7, etc. DSP, which that is digital signal processors. The DSP is a type of microprocessor specifically designed to process any signal. The architecture of DSP is fairly optimized to process signals in applications such as audio processing, speech recognition, image processing, radar, sonar, and smartphone, etc. Graphic processor. A microprocessor by Intel is made for high definition games and movies. Some examples are Intel 82786, Intel i860, and Intel i750. Moving on. Specifications of microprocessor. Here I have taken a small specification of Arduino Mega 2586 microprocessor. You can see at the left part the specifications, which is processor is 80 mega 2560, flash memory is 256 kb, data memory is 8 kb, EEPROM, that is electrically erasable programmable read-only memory, is 4 kb, digital input output pins is 54, PWM outputs is 15, analog outputs is 16, clock speed will be 16 megahertz, serial ports are 4. Let us see the applications of microprocessors in smartphones. Microprocessors are used in smartphones to to deliver seamless user experiences through their efficient performance, efficiency, graphics, camera, etc. And even it is used in gaming PCs because of these ability to the capacity of multitasking of these microprocessors are used in gaming PCs for maximizing the gaming experiences. Virtual assistant. Microprocessor help virtual assistants like Siri and Alexa, where like these are the Siri and Alexa we can see in the mobile phone, which recognizes our voice commands and interact with users. You can see the specifications of microprocessors, or we can say the features of microprocessor. That is architecture. The architecture of microprocessor refers to the organization of functional units such as control unit, ALU, and cache memory. Performance. The performance of microprocessor depends on clock speed, number of cores, cache memory, and the number of threads in it that can process simultaneously. And you can see the power consumption and compatibility part. Moving on. What is microcontroller? Microcontroller is a small computer on a single integrated circuit that is designed to control specific tasks within electronic system. It combines the function of CPU, memory, and several input-output interfaces on all in a single chip. Microcontrollers are widely used in embedded systems such as home appliances, automotive systems, medical devices, and many more. They are also used in consumer electronic products such as gaming systems, digital cameras, and audio players. So we can see types of microcontrollers, which is of 8-bit microcontrollers, 16-bit microcontrollers. Let us see 8-bit microcontrollers. These are the most basic type of microcontrollers, which is typically used in simple applications such as toys, small appliances, and remote controls. 16-bit. These are more advanced than 8-bit controllers, which are capable of performing more complex tasks. They are commonly used in applications like medical devices, automotive system, and industrial control system. Moving on. 32-bit microcontrollers. They are the most powerful microcontrollers which are capable of handling large amount of data and performing high-speed processing. They are used in applications such as gaming system, multimedia devices, and high-end industrial automation. And the next one is ARM microcontrollers. These microcontrollers are based on ARM architecture and are widely used in variety of applications including mobile devices, automotive systems, and industrial control systems. PIC microcontrollers, that is PIC microcontrollers. These microcontrollers are manufactured by Microchip Technology and are commonly used in a wide range of applications including home appliances, automotive systems, and medical devices. Moving on. Applications of microcontrollers. The first one is automotive industry. Microcontrollers controls everything from anti-lock brakes to airbag system in modern cars. The second one is medical devices. Medical instruments use microcontrollers to measure and control factors like heart rate, temperature, and blood pressure levels. The third one is the industrial automation. Microcontrollers are used to monitor and control industrial process efficiency accurately and safely. Specification of microcontroller. Let us take a small example of Arduino UNO microcontroller. Rated operating voltage will be 5 volts. Recommended input voltage level is 7 to 12 volt. Input output digital pins will be 14. Analog input pins is 8. DC current per input output pin is 40 mA, that is mega ampere. DC current of 3.3 volt pin is 50 milliampere. Sorry, that is not mega ampere, that is milliampere. Flash memory of 32 kb and SRAM, static RAM of 2 kb, EEPROM of 1 kb, clock speed of 16,000 kilohertz. Specifications are the features of microcontrollers. Memory. A microcontroller's memory includes program memory and data memory, which determine its capacity to run complex instruction and store data. Speed. The clock rate of microcontroller determines the speed at which it can execute instruction and complete tasks. Input-output interfaces. A microcontroller's input-output capabilities defines its ability to interact with the external environment like actuators or communication interfaces. Cost. The cost of microcontroller includes its manufacturing price, development tools, and software license, which affects its affordability and market penetration. Moving on. Let us compare between microprocessors and microcontrollers. In terms of functionality, microprocessors are more versatile and suitable for general purpose computing and complex applications, while microcontrollers are designed for specific tasks. Processing capabilities. Microprocessors are more powerful and faster than microcontrollers, capable of executing multiple and complex instructions in parallel. Power efficiency. Microcontrollers are more power efficient and less energy consuming, which makes them more suitable for battery operated devices and environments with limited power supply. Cost. Microprocessors are generally more expensive than microcontrollers due to their advanced architecture and processing capabilities, while microcontrollers are more affordable and easier to integrate with other hardware components. In conclusion, microprocessors and microcontrollers are versatile and efficient. Microprocessors and microcontrollers have revolutionized modern computing and made new applications possible with their powerful and energy efficient processing capabilities. Distinct but complementary. While different in their design, functionality, and cost, microprocessors and microcontrollers are complementary technologies that enhance each other's strengths and contribute to development of new solutions and innovations. Thank you.